Example 2, find the zeros. Example A, f of x equals x squared plus 4x plus 1. Now, find the zeros is just another way of saying x-intercepts. It's also another way of saying find the solutions. So if I want to find the zeros of the graph, which are the x-intercepts, the way we find x-intercepts is we substitute a 0 in for y. So we're going to have the equation 0 equals x squared plus 4x plus 1. If we solve this, we would solve it for x, which would give us the x-intercepts of our graph. The way we find our x-intercepts of our graph is we factor. So 1 times 1 is 1. Middle number is 4. So we need to multiply to 1, but add to 4. Well, if I'm trying to multiply to 1, my only option is 1 times 1. Does 1 and 1 add to 4? No. And there's no other option here, which means this is not factorable. So my first thought here is, okay, well, if this is not factorable, then maybe this doesn't touch the x-intercept. Maybe this is a no solution. But I want to actually go check and make sure what I'm thinking is true. So I'm going to go grab my calculator, x squared plus 4x plus 1, and look at that. It does touch the x-axis, which means it does have zeros. But if you hover, do you notice that it doesn't touch the x-axis at a whole number? When you're factoring is only going to give you a nice number, a rational number, a fraction, a whole number, something like that. This to me looks like it's not a rational number. It's probably irrational, but it does have two solutions. So our first solution, we're going to have negative 0.268. Our second solution, negative 3.732. So back over to our paper. X equals negative 0.268. Please leave all of the decimals. Second solution, x equals negative 3.732. And those are your zeros. Letter B, f of x equals negative x squared plus 2x plus 3. So if I'm finding zeros, I'm going to substitute a 0 in for my y value, or my f of x, negative x squared plus 2x plus 3. Now, before I use my calculator, I'm going to try to solve this by hand and see what happens. So if I'm going to factor, the first thing I'm going to do, I'm going to factor out a negative 1, which will leave me with x squared minus 2x minus 3. Let's see if this will factor. So we're going to have a negative 3 times 1. And then we're going to have a negative 2x, or a negative 2. If we try to multiply to negative 3, we can do 3 times 1. If I make the 3 negative, negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. This one will actually factor, so I'm going to keep going. Now, this was equal to 0. I'm going to break down my middle term into a negative 3x and a positive x. I'm going to bring down my minus 3. I'm going to bring down my x squared. And for right now, I'm going to ignore that negative 1. Grouping. Out of the first two, we can pull an x, which leaves you with x minus 3. Out of the second two, we can pull a 1, which leaves you with x minus 3. Then we can pull out the x minus 3, which leaves you with x plus 1. Don't forget your negative 1 equals 0. Now, before I do my zero product property, I'm first going to get rid of this negative 1. So I'm going to divide both sides by negative 1. That's your division property of equality. 0 divided by negative 1 is 0. And then I'm just left with x minus 3 times x plus 1. Zero product property, x minus 3 equals 0. X plus 1 equals 0. Add 3. X equals 3. subtract 1, x equals -1. So the zeros of your function should be 3 and -1. Just to check, I'm going to grab my calculator and graph it. Our original function was -x squared plus 2x plus 3. First intercept, -1, that's what we found. Second intercept, +3, that's what we found. -1, +3.